Okay, hi everyone. Can you hear me?
Hi, Abdur-Rahman. Yes, you're audible.
Uh, is my sound clear?
Very clear. And welcome again to PyTalks. We're
Yes,
waiting
thank
for
you very much,
Daily.
and sorry for keeping you all waiting. I got some mishaps, but okay. Yes, so I can start.
Yes. We also have Daily on the call, who is also the host. But however, you can start because of the time that we've lost. Just to catch up.
Okay,
I'm sure Daily will talk when maybe later. So yeah, please, you have the
okay,
floor.
okay, okay. Yes, thank you, everybody. So I wanted to talk a bit about AI trends, but from the perspective of builders. And as we know, we as builders, we have the opportunity to really do cool stuffs, but we also need to know what's happening under the hood. And so this is why I decided to present something about AI agents, but understanding where they come from. And so thank you, PyTalks, for hosting me and Python Nigeria for inviting me. It's a very great opportunity. And a bit about me. So I've been working with Python since a long time, and I also organize the local user group here in Mauritius. And yep, and we've had a very nice collaboration with Python Nigeria sometimes back for FlashCon. So yep. And if ever you want to see my slides, so here they are. You just scan the link. Yep. So let's begin. And let's say we wanted to build the AI agents from scratch. Let's say we are faced with in a situation. Let's say we were sometimes back when OpenAI just launched ChatGPT, and we were at this point of time where we had only chatbots and we had only an API to call. So, how do we build agents from scratch? Let's say we had this task to control a drone with your mind. So, every time you are tasked to interface with the physical world, it's more or less the same. And let's say you had to use OpenAI or Gemini to take off or land a drone. But let's say we were sometimes back, we did not know what the agents were. So to solve a task like this, um, we would use something called function calling. What we would do, for example, to control a drone, it's actually with a basic headset. It's not headset, sorry, with a basic Sky. Well, so we can call that a headset or sensor. So it just gives you a value. There are more advanced like sensors that headsets that you can buy, or you could set up more complex uh, arrangements. But the very basic that you can buy on the market is a headset that gives you a value, and based on that value, you do something. When the value is low, it means you are not focusing, and when the value is high, it means you are focusing. So yes, so we just want something very basic that when the focus is high, we leave the drone, and when the focus is low, so we land the drone. Very simple. So we have something called, let's say, get headset value, and then we move the drone up, we move the drone down, something like that. Get brainwave value. So we have get brainwave value. We have move drone up, move drone down, and to simulate what we need to do. And using function calling, so we have the name of the function to call, we have the description of the function, and if ever we had parameters, we pass them as a dictionary. And to control the drone, we continuously we monitor the brainwave value. We say to ChatGPT, here we have this value for controlling this drone. So tell us what to do. And what with the basic version of function calling, ChatGPT with OpenAI would just give us. We just need to call move drone up, or if the value was low, it would tell us move drone down. But why use AI in this case is that because we don't know what those values represent. We don't know what a low value is, what the threshold is like. We don't need to know anything, but we just tell OpenAI, just tell us what to do. This is the value, just tell us what to do. Process the contextual information and tell us what to do. So we see that with even with the basics of function coding, we can get enough things done. And yes, raw function calling is powerful. Let's say we had a task to create a ChatGPT plugin system. So let's say we were in that period of time where there were only ChatGPT. There wasn't any plugin, there wasn't anything like that, only ChatGPT. And we wanted to create a plugin system for ChatGPT. Let's say we wanted to create a SaaS, a software as a service tool that lets users use custom GPTs. So how do we proceed? So same thing, we just have a main function, we have our plugins, and in a folder, web search, whether air quality or whatever, and then we in each folder, let's say we have a main file that has a class plugin, and then we have name, description, parameters, and then we have an exec function. The idea is, and then what we do, we just iterate. We just iterate and put all those dictionaries here in the functions list. And then what we do, we, according to the user query, OpenAI would tell us what function to call. Just like in the case of, for example, move the drone up, move the drone down, or whatever. It knew according to the value I need to call this function, I need to call that function. Here also, based on the functions on the plugin description, it will figure out which plugin to call, and then it will return back the plugin name, the plugin parameters, and then we have an exec func which we just execute programmatically a function. We pass the parameters. It could have been eval, but let's say we write a custom function to do that. So we can see that even with raw function calling, we can do a lot of things, even controlling physical like hardware. Here we took the example of a drone. It could have been coffee machine, it could have been anything. But raw function calling is powerful, even when it's done. Like we are not executing any code. It just gives us what function to execute, and then we execute it. But even then, it's very powerful. Even for example, the example building a chat GPT plugin system. So raw function calling, it's very powerful. And even now, that was in the past, but even now, when we see like state-of-the-art toolkits for building agents, we see, for example, tools get weather, get current time, and then these are only functions. So we have the idea that function calling is behind is the meat of AI agents. Like AI agents, so what we call tools in AI agents is actually function calling. So it's only a rebranding. When I was building AI agents and I was researching around and I found that, okay, so what's new about AI agents that I haven't been aware of? I was searching, I was looking forward to, I was reading blog posts and everything. And I just came to the conclusion, oh, they just rebranded function calling into tools. So it's great to know what's behind those AI agent toolkits. They're just function calling behind the scene. And if we are as builders, we just use the toolkits to build AI agents. But when things go wrong, we have an idea of where to look for. And an AI agent is just, well, we have our prompt, then we have our LLM, we plan, we prompt the LLM, we connect it to a memory, we give it an array of tools, and then it does something, it gives us a response. This is essentially what an AI agent is. So we have the thoughts, the actions, and the observations, like what it saw, and maybe we want to do further actions based on what it observed. And generally speaking, we have the research phase, the planning phase, and the execution phase. And to build AI agents, you have different workflows, like different patterns that repeat every time. We have the chaining of action, like we have step one, step two, step three in sequence. We call the LLM, we do something, we call the LLM, we do something, etc. We just have like one after the other. So we also have like routing, the gating pattern, the routing pattern, where we we will go to step three or step five based on the output of step two. And we also have the pattern where we process results um, in parallel, or we aggregate different results, we collect them, and then we do something. We also have the feedback pattern where we prompt the agent, it does something, but the output was not satisfactory. So what it does what it did again, evaluates the output until it's satisfactory, or until we reach a maximum number of trials. Because let's say we are caught in an infinite loop, then our bill will also be very high. And then to build AI agents, we have from Hugging Face, we have Small Agent, which is very nice. And you have a light LLM model, which allows you to use different models seamlessly. And it's very nice. Whatever function you have, you just add the actual decorator, and then you have the response, and then you add the function as a tool. Yep, very nice. And we also have we can also have like different agents working together. Let's say we need to find the phone numbers of hardware shops. Let's say in a specific location, maybe we use some search like functions. So we need to search in a specific area or whatever. So typically we'd search for the website, extract the HTML, identify the phone numbers using regex, and put them in Excel, like different steps that we would normally do. But those steps, we can transform them into agents. And then we have the concept of graph agents. Like we have normal agents. Graph agents is more like for when using LangGraph. LangGraph is a great package for building graph agents. And LangGraph has the concept of state machines. And from state one, we go to state two, we go to state three. LangGraph is the same thing. And yep, so we have nodes. LangGraph has the concept of nodes. And then every time we move between nodes. And the nodes can have edges. The edge defines the flow. Let's say we want to return back. So we can have edges, we can have conditional edges. Let's say we are in a loop, but at some point we want to break out of the loop. So we'd have a conditional edge that check for a certain condition. And the condition is states, like we check for state values. Let's say I have many emails. I want to process the emails, maybe to format them, maybe to make them more beautiful or whatever, I don't know, or to classify them as spam or whatever. So in our state, we'd have the email text, and then we'd have the email status, like is it spam, not spam, or maybe you have is it spam is equal to false. But as we pass through the different steps, so we'll modify the state. Is it spam? It's false. Maybe it will become true at some point. When it passes through a certain node. And when moving from a node to another, the state, we modify the state. For example, here we have a flow where we have 3 nodes. We input the state to node 1, to node 2, and then to node 3. So in node 2, y was 2. In node 3, y is 3. So we modify, and then we present the final state to the user. The user is not interested into what processes has been done, but the user is interested into responses. So we present we have a beginning state, and then we have an ending state, and we do branching according to the flow. So I'd say that line graph is powerful because every scenario that you think of, every workflow that you think of, every new paper that comes up, they manage to implement it in line graph. So I'd say it's a very powerful framework, but since it's from LangChain, the API is very bad. And then something very nice, which is MCP, which I'm sure maybe you've heard of it, but it's a standardized protocol for AI agents to talk to each other. It's like a REST API, but a standardized REST API. We have servers, we have clients. Let's say you have a tool, an AI tool, you want people to access it. So you just wrap it in an MCP server, and then you expose it to the world, and then people on, for example, in the IDEs, people in, for example, Cursor can use it, people using AI agents, they can just access it. And yes, we also have data sources. A MCP request can be, it can be a request, a response, or a notification, like an MCP message can be of those 3 types. It just really JSON-P under the hood. It can communicate using standard IO or SSE. So it's just JSON-P, like nothing fancy. And in Python, to implement MCP is just like mcp.tool, add and mcp.resource, greeting name is the parameter, and then people can access it. Normally what happens, tools tools or IDs or whatever, so you just give them the MCP server, and then they will like have inputs for parameters that you need to put, so you can visually get a feel of what it's like to interact with that MCP server before you use it. If, for example, use lazy Vim, you have MCP hub that lets you interact with any MCP server you want, just to test it out. But just saying that whatever tool you have, just wrapping it into an MCP server is very easy, at least in Python. And yes, also MCPs gives us the idea of a marketplace. Just like for selling REST APIs, we have marketplaces. So for MCP also. And let's say an agent doesn't have any tool. So what we do, we just give it a registry of tools. So let's say it needs to execute an action. It will search the registry for tools, and then it will select an appropriate tool, and then it will respond. Just like our function calling was, but we gave it tools. But using an MCP registry, we just point it to a registry, and then our agent has access to a number of tools. Like it just selects the tool it needs to accomplish its task. It's really a very powerful concept. And it can even auto update itself. It sees what new tools came out and whether it will be useful for itself, so that we can have very powerful agents. But as always, MCP is the web, so you need to rate limit your requests. You need to think about authentications and prevent abuse. So different papers about agents, which is very nice, and the review is more about doing some savings for like for compared to normal React pattern, and that's some more things to see. And that's all from me. Yes, anybody has some question?
Yeah, good afternoon, Abdur-Rahman. Thank you for
Yes.
the session. We appreciate, really appreciate. It was nice having you around. Even though we started into the unscheduled, it was also, we do hope to still. I don't know. Can you hear me?
Yes, I can
Can you
hear you
hear
very
me?
much. Yes, I can hear you.
Okay, okay. Thank you very much. So, we do hope to have you back again next time for another session. Thank you very much from us at Python Nigeria. We really appreciate. I don't know if JTM is still on the call. If you can still hear me, so that
Yes, I'm on the call. Thank you,
all right.
Abdur-Rahman.
So over to you, Oga JTM.
Okay, just again to say thank you, Abdur-Rahman. And do you mind if you have some time on with
Yes,
you,
anybody
maybe for
has
some questions
some
or no?
question? What? Sorry, I did not hear you.
Okay, I was asking that if you have some time, just in case if we have questions.
Yes, yes. Any question, anything? And
Oh,
yes, I'm always around.
oh, okay, great. Maybe I should even be the one to start from start. So it's just like a discussion around agentic AI and all. And now you're talking from the builder's perspective around what AI agent. And I saw a place where you mentioned that the APIs from LangChain is somewhat maybe not that good. Okay, so
Yes.
considering the infrastructure we have in Africa, what do you think would be the ideal setup? We have and now I'm talking about the geographical area now. We have some limitation in Africa. One, data, infrastructure, and even the targets, the people we are trying to reach itself don't have much of this expertise. So, what do you think would be the best or the ideal implementation of AI agents in Africa? Again, from the builder's perspective.
Yes. I think it's just um, to not target only Africa, but to like put meaningful contributions, and I'm pretty sure the world will catch up on what someone, even if they're in Africa, are doing. We just need to provide, for example, if someone is offering a service, so they should provide a service that's up to the level that people expect. And yes, For me, I don't see this as a limitation. For example, if someone is really wants to invest some like money into the thing, so we'll always have Google Cloud, we always have everything. But from Africa, we provide the expertise. Like, um, it's true if someone wants like some local data centers or something, but I think maybe that's I don't have an answer to that. But classical like business things that sell is, for example, even for AI agents, is to build something good, and we'll use it. Normally, we just interface with popular LLMs, or at the very least, we interface with open source LLMs. But yes, I think if someone consistently showcases good works, so they can be like it will pick up by the world wherever you are. If you're connected to the internet and there are no sanctions or things like that, like pretty normal. So I think people will come, customers will come, or whatever you want. So I think there is like we should not like target Africa, but we should target people who are interested. Like
Generally.
yes, yes. Generally speaking, like building good stuffs, market it, building like your brand, and I think people actually don't care. People don't care if, in comparison, Mauritius, for example, where I come from, it's way it doesn't have the resources that, for example, Nigeria has. It's but opportunities come time and again. But I don't bet on the on the Mauritian market because it's maybe it's too small, can be too small. But even then, we have I have opportunities, but just saying that target the world.
Mm, mm. Okay, okay. Thank you for that insight. So we have a question from Philip. He's asking, what is the best tutorial video online to learn how to build AI agent from beginner to pro level, and the roadmap to become an AI agent developer?
Okay, so I think from experience, this talk actually I gave it sometimes back when like it was my findings about the AI agents. But since then, I built like stuffs. So I'd say learn one tool and learn it well. I don't know anything you pick. Pydantic has its AI. Google just released its ADK toolkit, Agent Developers Toolkit, or LangGraph, Monster, whichever you want. Then, when you use any of these frameworks, you just master it easily because you've already mastered one, and all the others they have the same, more or less the same concepts. So this concerning the building side of things. The second is to actually look what the patterns there are concerning LLMs, concerning agents. For example, I put some patterns here. For example, the feedback pattern, the gating pattern, the whatever pattern. For example, you have self-reflection, self-critique with reinforcement learning. You have planning. You have, I don't know, just see the world of pattern, AI agent patterns. And then in that toolkit that you've mastered, see how to implement those patterns in that toolkit. And there are two very simple tricks that you can use, that you use. Two concepts. One is conditional branching, like for example, in LangGraph we call that like the conditional edge, conditional branching, but you call that the routing pattern, that based on the output of a previous agent, so you decide which agent to use next. And how to use that, you just tell the LLM, okay, so I need to do this and that, and I have this and that. So just which one should I use? For example, you can ask it to output a JSON that tells you what to do next, or you can input some text that you pass, but a JSON is cleaner, etc. But the key to become an AI agent developer is to really see the different patterns, implement them. For example, multi-agents, find a good use case scenario for a multi-agent pattern, and then sorry, I got cut off. Yes, it's really about building agents, find different patterns, implement them, and because AI agents it's constantly evolving. I don't see even the land graph documentation. I didn't see a clear path for me to master it. So what I did, I just did what I told you. I found the different I found, pretty much the most advanced patterns for LLM, for AI agents, sorry, and I implemented it, for example, in LangGraph because I like LangGraph. Um, yes, so that's my answer. I didn't find a tutorial that really goes that deep.
Yes, that makes a lot of sense. I think finally, before we wrap up, one more question, maybe we can answer in just one word or a few sentences. So, if someone here, this is live and somebody is listening far and near, if somebody here listening to this session, to your session now, wanted to start or to start building their own AI agent this week, this is an interesting question because you just mentioned something now that things change over time. So, if somebody wants to build an AI agent this week, what's that one tool that you would advise or recommend they begin with or
I,
approach?
yes, I'd say try the Google ADK. It seems very popular among people because it's very easy. So try this, try some examples. It should be fine. Like you will get the basic building blocks. But the most like to implement patterns, you need some creativity. It's really crafting good prompts. Every pattern is essentially crafting good prompts. For example, yes, it's yes. So I'd say start, for example, the Google ADK Agents Development Toolkit, uh, Agents Development Kit from Google. The documentation is in Python. Like it has Python snippets to master it, to see the different steps that it has, and to use Gemini as your LLM because it has some free tier. OpenAI is paid, Anthropic is paid, DeepSeek I don't know, but Gemini is decent in terms of performance. I mean, not in terms of privacy if you don't pay, but it's decent. So use
Hmm.
Gemini, use Google ADK, like go over the whole documentation, try out whatever it's in the documentation. So tool-wise, when you're focusing on patterns, you won't be hampered by the tool.
True.
So, and then you see the tools, and you can ask an LLM, what is a roadmap for building AI agent or whatever, or you just Google or just ask Perplexity, what are some patterns that I can implement, and then you implement those patterns in your favorite toolkit. But you have to learn yourself because there are so many patterns out there that probably someone hasn't covered everything, but you need to find your own way.
True. Oh, I thank you so much for your session. It's quite interesting and insightful. Again, want to appreciate you for taking your time to share your knowledge and this experience. So it has given us some, behind the scene look as far, more recently, people see like some months back, people see LLM as AI, as the beginning and the end of AI. However, now we see what AI agent is and what is really going on at the back scene. So again, I just want to say thank you, and I want to believe. Did you share your socials, or how can we connect with you for
Yes,
listeners? If
I think this the slides where I shared like let me see the slides. Okay, this one.
okay,
Yeah.
okay.
This
All
one,
right.
it's
Thank you.
compileralchemy.com, or maybe, yep, it's compileralchemy.com. So there are like all my socials over there. And
Okay.
yep, so, and really AI agents, it just the prompt. For example, for a self-reflective AI agent, we just tell it, oh, see, you would give it an input. Like first you call it LLM. You say to it, oh, generate a plan, for example, a good holiday plan. Okay. Then you pass it to a second agent, agent. So that agent, you tell it, verify this input. If this input is good, input okay. If it's not good, input bad. Or input a JSON like status, good or bad, what needs to be corrected. Then what needs to be corrected, you call that same agent again. You tell it, okay, oh, those are the steps to be corrected. If it's okay, you put the status as okay, else you give the steps. So it will continue like that. You can also put a counter. If the counter is for example, greater than 10, then you just put the status to okay, else it will continue. But at least you have a refined output. But it's just prompting, It's really every pattern is just prompting. Yep. And it's just, first you define, for example, for line graph, every time the same thing. You define the state, you define your nodes, you define the flow, and then yes, it will run. Uh, but you just craft the prompt well. Um, it's really simple, but you just need to have some practice. Yes, that's it.
All right. Thank you so much, Draman. Yeah. So, so I would. I'm sure people would have gotten this your link, compileracademy.com, so people will be able to reach out to you. And also for the listeners, I want to believe you are all on Slack. If not, you can follow us on our social media platforms. We are on X, Python Nigeria, and also on Slack, Python Nigeria. Thank you everyone for joining the session again today. We'll be reaching out to you on all our social media again to for more sessions like this. Thank you, Abdur-Rahman. I believe we'll answer us when we call again some other time.
Okay, so thank you very much, and see you soon.
All right, bye.